Alright, in the last video we were talking about current. So obviously the amount of current depends on how much voltage you have. And voltage, sometimes called voltage drop or the difference in voltage, is kind of like we said, water going downhill. If the higher it is, the lower, then it's going to be steeper. It's going to be easier for more current to flow. If it's almost flat, then not so much. Same way if there's a big voltage drop or change in voltage and the electrons are pushed together versus not, then that's going to affect how much current will flow through. The other main thing that affects current is what resists the current, or resistance, or resistors. Anything that resists the flow of electricity through objects is known as a resistor. Okay. Now, a lot of times the resistance is just the wire. As things go through a circuit, then the wire has a certain resistance. Anytime it goes through an appliance or a light bulb or whatever, there's a certain amount of resistance that it takes to get through, and how much electricity is lost is trying to flow through it. Light bulbs in particular, because the resistance builds up heat. When something resists, a lot of the electricity is changed to heat, and that's why the older incandescent light bulbs with the wire in it that glowed would get so hot. Very large amounts of the electricity was changed into heat as well as light, about 3/4 of it into heat and only about 1/4 of it into light. So anything that is powered by electricity is also considered a resistor, because it's going to take some of that. The actual wire, though, of course, is going to be one of the resistors, because all circuits are going to have a wire to connect them. Now, some of the ways it affects it is, let's look at some of those. First of all, the width of the wire. Okay, and this is kind of like thinking about a river. If you have a wide river, you let more or less water go through than a narrow river. Well, the answer is a wider river. The wider the river, it's easier for water to flow through it. The narrower it is, the skinnier it is, the harder it is. So there's a higher resistance. So basically, the narrower the wire, then we could say the higher or the more resistance there is. All right? Or another way to put that, you could say the wider the wire, the less resistance there are. So bigger wires have less resistance than narrow wires. Okay, the length of the wire, obviously, if it's longer, there's more wire the electrons have to pass through. So you would expect that the longer the wire, the greater or the higher resistance it would have, the greater the resistance. Okay, the material it's made out of will affect that. Some things have a higher resistance than others. Okay, one of the very best conductors is Ag, which stands for silver. Okay, similar for silver. Also Au, which is gold. Both those are excellent conductors, and they are used when you need very good conduction of electricity through something. But obviously they're very expensive, so they're only used for very small things. Okay, you will notice like SIM cards, SD cards, and things like that. Various things inside the computers you'll look at. There'll be some things that are gold-plated, so it's actually using gold, but because it's a very, very good conductor. But obviously it's extremely small amount, so it's probably not very feasible to get that done. And other metals tend to be good. Copper is not as good as gold and silver, but it's less expensive, although it's starting to get more expensive, which is why you hear about people ripping wiring out of houses that are being built and stuff like that for the copper, so that they can sell the copper. But it's certainly nothing like gold or silver, so it's a better, and it's probably the most common that we use. Okay, and the metals continue to go down, and eventually you get to things that are not very good, particularly things like rubber, which is why rubber is used to coat the wire, because it keeps all the electricity on the wire. It doesn't let any of it escape, because it will not conduct the electricity through it. And so you can grab the plastic or rubber coating around the wire and not get electrocuted. Okay? So just depending on what kind of material it has that it's made out of is going to affect the amount of resistance the wire has. All right? And the last thing we're going to look at, the temperature of the wire. Okay? Basically think about it like this. If this is a wire, use your imagination, okay? And remember, it's made out of atoms. And even though these atoms are going to lose their outside edge ones, there's still a bunch of atoms in here. The electrons can flow between these, but think about it. Is it easier for them to flow between these if these don't move very much, or if they move a whole bunch? As the wire gets hotter, the atoms, we know, tend to vibrate in place faster and faster and move back and forth. And so it's a lot harder for the atoms, because they may hit it and bounce off. And so it's a lot harder for the electrons to flow through it if it's hotter and the atoms in the wire are moving faster. It's kind of like if you're trying to walk across the street. Well, if the cars are moving very slow, it's very easy to weave your way between them. But if they're moving faster, then it can be very difficult to get between the cars. Well, the same way with the electrons in electricity. If the atoms are vibrating very fast, it can be very hard to walk between them all. But if they're going very slowly, then it's a lot easier to flow around them. And so basically then we need to say that the hotter the wire, all right, then the greater the resistance, okay? And that kind of just makes sense, but we just want to put that down, all right, to do that, all right? Now, that means the colder it gets, then it's easier for water, and there are some substances that are known as superconductors, and what this happens is these are ones that are very near to absolute zero, and they have almost no resistance. As they get closer to absolute zero, they have absolutely no resistance, and these substances are called superconductors because there's so little resistance. They have a very good flow of electricity through, a very good current going through them, and very little of it is lost to heat and so forth as it would normally be during resistance. Okay. Now, before we finish up with resistance is measured in units. Okay. Voltage, I'm sorry, we didn't really say, but is volts, like 120 volt outlet. But resistance is also measured in units, and these units are called ohms. Sounds like something a yoga teacher would be doing, or om at the top of the room. And they are measured, the symbol for that is the Greek symbol omega, which looks a lot like a horseshoe kind of thing. And that's the symbol for ohms, and that's what we measure resistance in. So basically we've said there's two things that affect how much current is flowing through the wire. One is the amount of voltage or voltage drop, the difference in voltage at the two ends of a circuit, and the resistance of the materials in the circuit to the flow of electricity, which is the resistance, okay? And so those are basically the three things that all affect each other, and ohms, for example, are called that because Georg Simon Ohm, a German physicist in the 1820s, about 26 or so, he came up with what we call now Ohm's law, okay? And Ohm's law was just a relationship between these three things, which we've already kind of talked about, but that's what he came up with, all right? And he said that Ohm's law says the current is equal to the voltage divided by the resistance, which makes sense. As the voltage increases, there's a bigger drop or change in the voltage throughout the wire. It's going to flow faster, so it's going to increase your current. So as voltage gets bigger, the current gets bigger. The bottom number in the denominator, as it gets bigger, resistance gets bigger, it's going to make the number smaller, so you're going to have less current flowing if there's more resistance. So if we want to increase the current, we either have to apply more voltage, make a bigger voltage drop, or we need to reduce the resistance. Either one will work.